In celestial navigation, lunar distance is the angle between the Moon and another celestial body. The lunar distances method uses this angle, also called a lunar and a nautical almanac, to calculate Greenwich time. By comparing that calculated time to the measured local time, the navigator can determine longitude. The method was used for some time during the 17th century, before the introduction of the marine chronometer. A similar method uses the positions of the Galilean moons of Jupiter. In celestial navigation, knowledge of the time at Greenwich and the measured positions of one or more celestial objects allows the navigator to calculate latitude and longitude. Reliable marine chronometers were unavailable until the late 18th century and not affordable until the 19th century. After the method was first published in 1763 by British astronomer Royal Neville Maskelyne, for about 100 years mariners lacking a chronometer used the method of lunar distances to determine Greenwich time as a key step in determining longitude. Conversely, a mariner with a chronometer could check its accuracy using a lunar determination of Greenwich time. The method relies on the relatively quick movement of the Moon across the background sky, completing a circuit of 360 degrees in 27.3 days. In an hour then, it will move about half a degree, roughly its own diameter, with respect to the background stars and the Sun. Using a sextant, the navigator precisely measures the angle between the Moon and another body. That could be the Sun or one of a selected group of bright stars lying close to the Moon's path. Near the ecliptic, Regulus was particularly commonly used. At that moment, anyone on the surface of the Earth who can see the same two bodies will observe the same angle. The navigator then consults a prepared table of lunar distances and the times at which they will occur. By comparing the corrected lunar distance with the tabulated values, the navigator finds the Greenwich time for that observation. Knowing Greenwich time and local time, the navigator can work out longitude. Local time can be determined from a sextant observation of the altitude of the Sun or a star. Then the longitude is readily calculated from the difference between local time and Greenwich time at 15 degrees per hour. Thank you for watching. For more educational videos, please subscribe to WizScience on YouTube or visit wizscience.com.